All right. All right, everyone. So let's do some introductions and kind of lay the land here. So if it's your first time hopping to one of these events, my name's Ryan. Go by the handle No Autopilot. I'm the community manager for Vi Worlds. And with us today, we actually have some pretty special guests. Smasher, why don't you go first, if you don't mind, and just kind of introduce yourself and what you do for Knock Knock.
Sure. I'm the head of technology at Knock Knock, and that means I head up the engineering department and do all things technical.
Nice. Yeah, Smasher's my favorite person. I always ask him a complicated question, and he's like, "Yeah, it's not that hard. No problem." All right, and then we also have a couple team members from Befio. So, Christoph, do you want to go first and introduce yourself?
Hello, I'm Krzysztof Jankowski, that's pronunciation, from Befio, and I'm the project manager for the stuff that we are doing for the project. And also with us is Tom. Tom, can you say something about?
Hello, everyone. My name is Tom. I'm a creative director at Befio and the founder of the studio. I'm responsible for making everything looks beautiful on the art level, making sure that the VR worlds is going to look as beautiful as possible in terms of visual, but also technical sometimes.
Awesome. All right, yeah. And so, so from our community here, we kind of have a nice cross section. We have a handful of moderators from Vi Worlds, so people who help keep our community happy and healthy. We have a handful of builders, so the people who are actually using the game assets that you guys create to build experiences within Vi Worlds. And then we have a handful of new people who only learned about Vi Worlds like yesterday in a Let's Play. So, with that said, Smasher, do you want to kind of, I guess, get us up to speed on what we're looking at here?
Sure. Yeah. Little background. We don't have a huge art staff at Knock Knock, so we've been doing some of the art internally, but then we decided to outsource to Befio and have them create a lot of the 3D objects. So all of the 3D objects we'll be looking at today are Befio's work. I don't take credit for any of it. And these are things that are going to be going into the game very soon. So if you see things here and say, wow, that looks like way better than what we have in the game right now, that's because this is the new art that is on the way. And I'm just going to try to pull up one of our existing trees to compare to this lovely new Befio tree. Let's see what a tree V3 looks like.
And then just a quick heads up. So it sounds like we have people popping in and popping out. I don't have a way to mute that, unfortunately, that noise. But yeah, we'll probably hear that throughout as folks are able to hop in.
All right. Well, the more the merrier. Why not? Yeah. So here's one of our existing trees, sort of modest and has been working all right in the game so far. And this is an example of one of the trees that Befio created. And it's
Hey Pablo, will you put yourself on mute for me, bud? Thank you.
And probably one of the first things you'll notice is that there's quite a bit of asymmetry to it, which is really nice. And this rim lighting around the edges, you can see that sort of yellow and white highlight around the edges. That's called a Fresnel effect, and that's part of the shader that Befio wrote for us that we're going to be using on a lot of the objects.
So, can I ask you a quick question there?
Sure.
So, what I know Friday mentioned it yesterday too, but what is a shader?
What is a shader? So when people say there are two different types of shaders, but when people say a shader, they're usually referring to what's called a pixel shader. And it basically is a computer program that takes a bunch of inputs like the textures, the images that are laid onto a 3D object, and the geometry of the 3D object, and it returns a color that gets displayed on the screen. So for every pixel on my screen, for every like display dot on my screen, the shader runs and says, what part of the 3D object am I hitting? What color is that 3D object? What image does it have applied to it? And based on those things, what color do I output to the display?
Wow. Okay. How um so how does that work when you're building like a browser-based game, right? Because like there's some technical limitations there. It sounds like it's pretty efficient, so it's able to kind of balance those two things.
Yeah, well, it's running. This particular shader is running thousands or possibly millions of times. Like I said, once for each pixel on the screen. Your video card is really good at doing that. Like that's why your computer has a uh, separate chips and graphics chips in the video card. They do this stuff really quickly in parallel. So they can handle, hey, I need to do this for 1 million pixels. Sure, no problem. We'll do them all at the same time in parallel. That's what your video card does. That's what your GPU does. And for browser based games, the browsers expose some bits of code that we can call that say, load up these images, load up these shaders, and send them off to the video card. So for web-based games, the shaders have to be compatible with WebGL. You may have heard of OpenGL. That's one of these translation languages. That's one of these interfaces that you use when you're creating 3D graphics. You write code that uses this other code from OpenGL. So in this case, if the shader is compatible with WebGL, then we can use it in a web game.
Hey, I don't know about anybody else, but you're blowing my mind right now. This is awesome. Okay.
All right, did I throw in any new terms that I need to define there?
Um yeah.
Maybe for some of the newer people, but I think in terms of open, just keeping the flow going, I think that's a good start.
Yeah.
Okay. Okay. All right. Yeah. If the one thing I don't have open is the Discord chat window right now. I'm running it single screen here. So if I do use terms that people don't understand, put them in the chat, and Ryan will let me know.
Yep. We did have one from Gandalf the Red. This is a quick question. He said, so on your PC when you're playing Viworlds, does it matter if I have a better GPU?
Yes, it does. In fact, one of our product people, Maestro, that you may have met, he has a very nice gaming rig, and he consistently gets greater than 60 frames per second. In fact, when we had I don't know if we had the frames capped right now, but we used to have it uncapped, and he would get 120 frames per second on his rig because he just has a mad machine that he uses for streaming his FPS games.
Yeah, I think on my stream the other night when we were playing a Let's Play event, I was able to reach upwards of 90, not even at, and I was streaming too, so I lessened it. So
Nice. So in general, we are targeting more modest machines. My development machine here is not gonna blow anybody away with its frame rate. So we sort of target more modest machines, and we don't try to push them to their limits so that more people can play.
I had a quick
But yeah.
question. When it comes to the way that Worlds is doing it its play in terms of being hosted on AWS and stuff. since a lot of the rendering and things is being assisted by AWS. What's your thoughts on the future of how that goes?
Oh, okay. So we're not doing like a cloud gaming system like what's the Google one, Stadia. Like that's not the sort of thing that we're doing. We don't have GPUs running in the cloud or anything like that. So really, the only thing we use AWS for is storing a lot of assets. Like when you download the level file that comes from S3, the skins, your NFT skins that you've purchased, all of the artwork that they use, the textures, the models gets downloaded from S3, and then coordinating between multiple clients. We have a server on S3 that says, oh, this player moved. Okay, tell all the other clients that this player moved. So as far as rendering goes, it's all done locally on your machine, and we just use AWS for the server to coordinate the positions and the timing of things like drawbridges and cannonballs and things like that. Does
Okay,
that
so
answer?
yeah, absolutely, because that's a big clarification for some people that think that possibly that um, the entire rendering is done in the cloud, whereas what you just specifically mentioned is your device does matter that it's being played on.
Yes, yes. Your local device does very much matter. But actually, and those sort of limitations do impact the art. It does impact the number of triangles that you can have in the art. It does impact how complicated the shader can be. So when we started working with Bethio, we said to them, hey, this thing needs to hit 60 frames per second, and it needs to do it on an iPhone 10,
Correct.
which is a couple years old, but
You have to set a
GPU
baseline.
wise is kind of a beast. Like it was really powerful for the time that it came out. So if we can hit that target, it should work on a wide variety of machines. But your local machine does matter.
Sweet. All right, Smash. I think I took you off course a little bit. I'm sorry. Continue.
No, do not apologize at all. I'm happy to digress and go off into the woods. So please let me know if other questions come up.
Sounds good.
All right. So we were talking about this tree, and I'm just going to point out some things that were interesting to me because they are it's different than other 3D projects that I've worked on. I worked on Avengers Academy and Harry Potter Hogwarts Mysteries when I was at TinyCo, and we used a very different texturing technique on the 3D models there. The artists would create the entire model, and then they would take it into another program like Photoshop or Substance Painter or one of these other programs that artists use to paint textures onto a model. And then they would paint the whole thing top to bottom. So this is sort of divided into 4 sections, and you would see all 4 of those sections in the texture. Um, and that is sort of distinct from what's happening here. Just a moment, I need to locate the texture here.
Hey, Smash. And one quick call out.
Yes.
I'm not sure if it's like maybe you're tabbing off of what you're showing. But like right now, it looks great, but periodically it'll flicker your display.
Okay. I'm not leaving Cocos, but I will let me know, I guess, when it happens again, and I'll try to figure out what I'm doing.
Okay. All right.
Okay. So I don't know if you can see down in the bottom corner here, this 512 by 512. There's something that looks a little bit like a white barcode with some little ticks along the bottom of it. Is that visible?
Yes.
Great. So That is actually the texture being used on the at least the top part of this tree. And you might see that it doesn't have 3 levels to it or anything. It's just one texture that has been applied. But if you look closely, you can sort of tell how it's being used. The texture is used once at the top up here to get this little green tick, and then it's used again in the middle, and then again at the bottom. Bethio team, is there anything that you want to say about this texturing technique or the way you paint the textures?
Yes, we can elaborate a little bit on that. Basically, the technique which we have used is quite known for, especially for creating video games assets. And we, as Marshall said, for us, not only the art was important, but also making sure that the models will be optimized and work like on every PC smoothly. So that's why we have created a technique which is called trim sheets. So basically, we are using one texture and reapply this on every model by hand. So artists have to open the UV map system, something which is related to basically mapping 2D texture into 3D object. And by doing that, we are able to manually tell the software, oh, we would like to have this texture on this place, or maybe that place, or maybe this detail is not the way how we would like to be. And doing this way, we are able, first of all, still use just one texture, so it is very optimized, and we are reusing basically one texture on the whole object. But second of all, we are not limited in terms of like visual aspects, because we have a control. And this is basically the first step of creating this tree model or every model. So there are next steps, but I can elaborate later on that.
Okay. All right. Just say the word. Say the word when you want to jump back in again, and I'll give you the mic. One thing you may notice about the texture is the texture I'm showing down here in the corner is entirely black and white, or at least entirely white and shades of dark gray. But the tree itself is obviously not black and white. It's appearing green and some shades of yellow there. What's happening there is we are only pulling the texture is being applied on top of some other existing colors. The actual 3D model itself, I said earlier that a 3D model was, oh no, I didn't. I probably said the word vertices or vertexes. A 3D model is made up of a series of triangles defined by 3 points. If you place 3 points in 3D space, that defines a triangle. And then this model is made up of hundreds of triangles. Each of those little points that are used to make up the triangle is called a vertex, and you can assign those a color. You can say this particular point hanging in space is green, and this one is yellow on the other corner of the triangle, and on the third corner of the triangle, it's blue. If you define those 3 colors, the triangle itself will have a nice gradient that averages between those 3 colors, or interpolates between those 3 colors. It changes as you go from one corner of the triangle to the other. So that's where the green and yellow body parts here, you can see that's like some soft yellow in the middle and some darker green at the bottom. That's coming from the vertices of this model. And I'm actually going to see if I can, down here in the corner is the model with no material applied to it. And I was really hoping to see just the vertex colors there, but it's not cooperating. But if I change this material and turn off the texture, turn off the image that we're applying. Nope. Yes. There we go. If I turn off all those maps, now you can see, and there's some Fresnel as well. Whoops, nope. There we go. I think I got it. This is what the tree looks like without the textures applied, just using the vertex colors. The little points that make up the triangles are each given an individual color, and that's what gives this soft, like it's almost not a watercolor effect, but a very washed, a very wet watercolor effect, a very blended watercolor effect to this tree.
Question for you, Smasher. So, what's the process of like a piece of art being created or asset being created and then it being like brought into the game? Like we've seen some like the cool blocks that people put together. Like, what does that process actually look?
Sure. So I can pick that up from the point that Beffio creates a 3D model, but I'll let them start with the beginning of the process, where they, I suppose, start with a concept drawing and go from there.
Yeah, I think I can elaborate a little bit.
Okay.
We before started from when we got the final accepted concept from you. So when your artist done the concept, we need to see the object from different aspects, and also what is important to have the scale. So we have also there that VGuy to make this know what's the scale of the image, and then we're taking that to the 3D artist, and basically the 3D artist first make the base model in Blender. In our case, he's made the base model, check the scale, and if everything's okay, and if the model looks nice, of course it's needs to be optimized, so it have not so much of those polygons or triangles, as you said. And if everything's okay, it look good, then the next step, well, there's lots of steps, but next step is to make those colors on the vertex color. So he paints the model according to the concept. So he have something like you are showing right now, more or less. And when that's the colors are okay, then he adds all the details. So he for some of the items we already have those textures that those black and white textures that you showed, with also with the normal maps. So if the texture is already there, he just takes it and apply it to the new model. Like for making new trees, he will just reuse those, and also in the bottom for the branch those another texture. And if it's the new thing that needs to be created, then of course he is making those texture for reuse for other objects. Oh yeah, exactly. And then he adds also, we are creating the normal maps that right now, when as you yes, click at this, you can see that there's the normal maps shows tells the graphics card how the reflection of the light is handled. So it's faking the dips and basically adds the depth, but it's only in the texture and it's faked. So when you see it like that, you see that there's like more of the depth.
Yeah.
So he also add this reuse or make new one and then reuse. And basically when the whole model is done with all of those stuff, we put it in the Cocos, check it how it looks like with the environment, do some screenshots, show it to the Knock Knock, and then when then the designer that makes the first concept look at this and say it adds some feedback if there's need, or just accept it if it's looking quite good. I think that's the more or less whole process.
Great. Excellent. Excellent. I just want to go back and highlight one of the things that one of the things that Christoph mentioned was the normal maps, and I was clicking that on and off here. You can see the sort of, it looks like there's ridges carved into the bark here. It looks like there's raised and lowered sections of this bark. That is totally a trick of the light. That is completely, let me turn it on and off again. Off, on, off, on. That is just a trick of the light. That's one of the things that the shader does. The shader takes this, this is actually another image. Let me see if I can find that image here. You see this image down in the corner here that looks sort of purple and blue and pinkish. This is what a normal map typically looks like. And this is a special kind of image that sort of defines, if this was a real object, what angle would the surface have? And the texture is made up of red, green, and blue channels. So the red channel, the red number, is used to define the X angle, or maybe it's the Y or the Z. I'll get them all mixed up, but each of the colors corresponds to one direction, X, Y, or Z. And the final color sort of tells you this point on the object, where does it face in space? Where is it pointing? And then the shader actually does its math and says, okay, based on the position of the light and the imaginary angle of this little bit of the object, what sort of shine should we put on it? And the lighting, and as opposed to putting it in the regular texture where the color would just be fixed in place, these highlights actually change when the lights change, when the light moves, and when the camera moves. And that is normal mapping. But it's all sort of a trick of it's all sort of a trick of the light. It doesn't actually add faceted surfaces. It doesn't add a real surface to the object. If you could run your finger along it, you'd find that it's still perfectly smooth. It's almost like a TV that's showing you these ridges on top of the object. And where it breaks down is when you try to look from the side, when you try to see these edges from the side at the very edge of the object, you can see there's just nothing there. The object is still perfectly smooth, just like it was before we turned the normal map on. And these ridges are really just coming from that texture.
You know what's wild is like I've been playing video games my entire life, and I've just taken that for granted. Like I had no idea that it's just a trick of the light creating the appearance of texture. Pretty cool.
You have been staring at these normal maps all your life and not knowing it. Can I move the light here? Where is the light? Someone give me a light.
While you're doing that, we did have a question pop up. This is from Pablo P. Pablo. He said, how is the performance of the new blocks compared to the old blocks? Also, can we see the bottom of the tree trunk on the trees?
You're trying to get a look at our dirty undies, aren't you? Let's see. How's the performance compared to the old one? It is very comparable. I don't think there's one object that used a lot of particles that may be a little bit slow, the portals, but our old portals were also terribly slow. With our original objects, we left a lot of performance on the table. We didn't push the system very hard. So we had a lot of performance to spare. So that meant we had a lot of headroom when creating these objects, and the performance should be comparable. We haven't done the full suite of tests yet. we have a test script that we can run that basically adds 500 objects to the screen. First, it'll add 500 portals and then check the frame rate, and then it'll add 500 lava and check the frame rate, etc. Once we've finalized all these objects, we're going to run that script, and then we'll get a big graph of what our really speedy objects are and what our really offensively slow objects are. And then we'll be able to fix those up before we go live.
Sweet.
Remind me to run that script later because it looks ridiculous. It's pretty funny.
And we are recording this too, so maybe I can turn that into a GIF or something. That'd be cool. Okay, so we had another question.
Oh, the trunk of the tree.
It's just a basic tree trunk.
The cake is a lie, folks. The tree has no tree trunk. It looks like it has no bottom, and what we're seeing here is a little mysterious. What we're seeing here is a little strange, but again, it points out the fakeness of 3D objects. What we should be seeing, that the bottom is missing. The bottom is completely not there. What we should be seeing is the inside of the tree trunk and the inside of the root. But those triangles, those surfaces are marked as one-sided. So you can see as soon as we try to see the backside of them, they disappear. So, dirty undies, don't put a tree in midair. That is fixable either in the surface or the shader. We can mark the object as double-sided, and then at least you won't have disappearing bits. You won't have disappearing parts there.
All right, Pablo P. There you go. You deviant. Got to see what you came here to see.
Yeah, you're seeing triangles that are facing away from us and not getting drawn. That is called culling. That is called culling. And now that I've remembered the name, if I find the checkbox, I can probably change the culling mode. Oops, wrong material. Abort. Culling. I saw it a second ago. Options for culling the back. Culling the front. That looks truly bizarre. Now anything facing towards us is not being drawn, and anything facing away from us is being drawn, and we get sort of an MC Escher twisted physics going on. And then if we set the culling to none, boom! Now you can see there is no bottom on this tree, and you can sort of see into the spooky interior. And we can look straight up its shaft. There you go. How's that? How's that spooky?
That's hot. Wow. Good stuff.
Yeah. Oh, but I'm glad you asked though, so that we could talk about culling. Oh yeah, I've completely wrecked up this tree. Remind me not to save this object.
We'll just call this the Pablo P tree.
Yeah. Yes. Oh, Siri, put this on the Pablo P branch. Okay. We've spent an exceptional amount of time just on this one tree. How about we go look at another object? We must have some more around here somewhere.
Can I add something to the process of creating? Because I forgot about one very important thing that is also a little bit time consuming, but making the tree looks awesome. It's most visible on the other tree, the maple tree. If you can put maple tree, that will be better.
I can indeed.
Yes, weighted normals, because those trees and all of the items look so smooth. And to achieve that, the artist also spends a lot of time to make sure that all of those polygons have right normals, and when you move them and see them from different angles, they always look smooth. And also with those trees, not all edges, but also there's also edges, are smooth. So some edges are hard edges, we call them hard edges, and then you can see that you have those like chopped parts, but the other parts, other things are smoothed, and the artist needs to spend a lot of time to make whole tree or whole model looks nice and have all the smoothness right, because it's easy to make it that you already see that the thing is not smooth. When it's already done right, then you don't see it. It just look beautiful. But when you don't spend time on that, the tree will look not that good, and sometimes even awful because of that wrong smoothing. So that's one of the parts that's taking a lot of time, when especially with this type of tree, when you have hard edges and soft edges and a lot of those blobby material or mesh.
Okay. All right. Great. No, that's an excellent point. The smoothness that you're seeing here, this looks like it's round and smooth like an apple. Um, you might say to yourself, there must be a lot of these tiny triangles in there, right? Like they're in order to get this thing look smooth like a beach ball, there must be a lot of triangles. And that's actually yet another trick of the light that Christoph was talking about, where the vertices that we talked about before, you can in the 3D modeling program select a vertex and say this vertex is pointy. All the triangles that intersect here will come to a point. Or you can say it is smooth. I would like it to be rendered smooth. So that's the difference between sort of the sharp edges and the soft rendered areas that he was talking about. And again, you can see the lie when it looks like the front of this is very smooth, but I'm going to rotate the camera so you can see it from the side. And actually, and in fact, it's this thing is like blocky like a Pac-Man. But again, the renderer, the shader, and the 3D rendering system do the trick of making it look smooth for you, because you've told it, I want to interpolate, I want to smooth out the rendering and the normals along this this angle of this triangle.
So let's take like the tree for example. From start to finish, like, how long does that typically to create, like in game?
Basically, that of course depends on the model or the complexity of the model. Those trees, especially those maple trees, those took way longer. Like some of the easiest smaller items that we see in the background, those could take a day or two, sometimes a little bit longer if we need to make a whole pack of new textures. Those trees, the base model could also take like few days, but making those smooth and hard edges look good, as you can see on the tree on the left, the first from the left, it has a lot of smooth and hard edges, and to make it look good, that could take even a whole week just for making those smooth and basically changing each of the polygon to look good. So
Cool.
it depends, but it's in the terms of like few days to a week, compared to other elements that can be done in a day or half a day. If we have all the textures and all the material, we just need to make a new box, let's say, as we see in the background.
Cool. Thank you.
Great, excellent. I'm just going to try to break this apart a bit. You can also see that it has the normal maps used in the other places, and the somewhere there should be a detail map. That's the oh yeah, okay. So that's what it would look like if we didn't have any of these maps turned on. And there was one other thing that I wanted to toggle off, but I have already forgotten what it is. So moving on. Let's get out of the woods for a minute. Let's look at something else. Let's look at the trampoline. You can see there are some very shiny bits on the trampoline here. This is, and you might have noticed it before when I pulled in one of our old trees that suddenly became shiny. These balls are shiny. You can see some nice in the facets of those deadly objects. You can see some nice reflections. Can I get an ooh and an ah? Oh, everybody's muted. Thank you, everyone, for being muted.
No, all of our jaws have dropped.
Oh, okay. All right.
Yeah, we're speechless.
Yeah. So this is something, an engine feature that we just didn't have turned on in the game before. An environment map. You can define an environment that basically says if something is shiny, what is it reflecting? Like, what is it going to reflect back to you? And you might think that that's kind of obvious. You'd be like, well, we have all these clouds here. Like, it should just be reflecting the clouds. Um, these clouds are totally fake. We used to have a bug that would let you see this, but whoops! Now we've seen that. Now we've seen the cafe as well. We used to have a bug that would let you see this, but the sky is just a cylinder. The sky is just a cylinder with a texture mapped onto it. Whoops, I lost it again.
I like how there's just like
Basically,
yeah.
sorry.
Mm-hmm.
I just wanted to say that this is a matrix. That's why there is like a room inside the room inside the room.
Yes, it is. Now you're really seeing outside the matrix. So the sky that we've been using in the game so far is actually just a single square image that we repeat 3 times and wrap around a cylinder. And that was a method that we used because it was very easy for our 2D artists to just draw a square image in Photoshop and use that. But this sky is really just a 3D object that we can turn on and off, and it doesn't have any real reflective properties. Let's see. You may still be asking yourself, like, why doesn't the sky reflect on a reflective object or something like that? Or if I bring a tree over here, will I see the tree reflected in the shiny object? And I'm going to ruin video games forever for you guys. But the tree is not reflected in the shiny object. Because again, this shininess is all faked. You may have heard about video cards that support ray tracing and whatnot. RTX off, RTX on, RTX off, RTX on, right? Ray tracing is one of the technologies that you need in order for 3D objects to really, have 2 balls reflect the image of each other, or do the MC Escher holding a chrome ball in your hand and seeing a reflection of yourself in the chrome ball. Like, that is all stuff that is possible with ray tracing, but we are not doing ray tracing, which means it's actually not supported by WebGL yet. So any reflections that you see have to be faked in some way. And the way that this is faked is using the environment. For the scene, we define like, hey, this is the environment that we're going to use, and this one came from Befio. Is this a common test environment, or is this something you guys just use
Yes,
internally?
yes, it's just like one of the testing thing, because in the end, in the final project, this environment should be as close to the to your 2D clothes and those blue texture as possible. Not some room, but for testing purposes, it's very good because you clearly see the reflection, and when the artist tweak the roughness value, so the reflection value, as you can see, the star has 0 reflection, which means reflect everything, and the blue parts between those are more matte, so it has a higher value of roughness. or its smoothness, depends on the engine. Yes, it's roughness tab, 0.18. Yeah, exactly. So it's going from very reflective to not reflective, and we can see clearly using that environment map. But it's easy to change that to any other environment, and also this change a little bit of the mood of the game when you have a lot of those reflecting elements.
So
Yeah, this is a good environment because it has light and dark areas. Like you can see the light from the windows and the light from the chandelier, and that gives you something to reflect. Like you really need to have something to reflect. Um, our sky is just a big blue box, so we need an environment with some more details in it before we can start using. We can't just use these clouds, or you would just see a big blue nothing above your head. Were you asking, Ryan?
well, yeah, so my mind's kind of blown right now with the Matrix comment, but so so all this time we've been in a cafe.
This is actually just something we haven't. In the game that you're running right now, if you turned off the sky, you would just see a black box. This cafe is just coming from right. You would just see this. You would just see this,
Well, that's
or are there
terrifying.
something darker in the game right now? Um, this cafe is only on the Bethio testing branch. They've been doing their artwork over here on their own branch of the project, and they added the cafe in their branch.
Okay,
So
gotcha.
I wish I don't add that to the maker lore. Don't add that to the wiki that this is actually, a game being played in in a cafe.
Yeah, just
Uh,
platforming over a lemon cheesecake slice. I get it.
yes, exactly. Such deliciousness. Um, so yeah, this is just something test in their branch, and we will replace this environment, as he said, with something more appropriate for the game.
So we did have another question pop up. Sorry, Gandalf, I think I missed it. But he said, question, would it be possible to give the option to put the FPS higher? 44 asked.
So when we have not done that because we don't have a great way to test it. My dev machine and the other engineers' dev machines can't hit those frame rates. So if things like physics bugs pop up at those frame rates, we have no way to test, reproduce, and fix them. So we would have to make a considerable hardware investment before we could even consider that. As to whether it's technically possible, I don't know if really the question is, will browsers support those frame rates? Will Chrome and Safari let you go over 120? And I am not sure. I don't know.
Awesome answer.
So it is not on our roadmap right now, but and there are some speed bumps involved.
Yeah,
I can add that.
go
I
ahead.
can add that basically you will be able, if the engine doesn't have the cap, to have higher frame rates. But basically, first of all, the engine needs to support that, and you need to have less elements on the screen and super beefy computer. But then the physics should be, if the engine is able to change that, physics should be capped at 60 or 30, and then rendering of the meshes can be uncapped on whatever you want to have. Also, there's a VSync, so you need to have 144 hertz monitor to have like smooth visuals with those higher frame rates. So there is a lot of things that needs to support this and needs to be tested and so on, and to have those high frame rates.
Thank you. That's great. Yeah, spoken spoken like someone who's done PC and console development before. I came from mobile development, so I'm used to whatever Apple provides us, we can turn on and turn off.
Hey, so
Mhm.
real quick. So I have a Let's Play that I'm hosting in another Discord server in 5 minutes. But
Okay.
that doesn't mean that you guys can't talk more. If Mash, I don't know what your schedule looks like or if you need to jump as well. But I just want to make that call out that in a couple minutes, I'll probably need to exit stage left for the next event.
Okay. All right. Thank you very much for your help. I can stay on until my I'm in California and I'm supposed to have some guys in to earthquake proof my house. If my earthquake guys show up, I'm going to have to bounce, and that may be somewhat suddenly, but otherwise, I can carry on for a bit.
Awesome.
Is anyone else available to watch the chat and maybe kind of act as an MC, act as a second voice here? Any volunteers?
Mark, do you mind if I volunteer you? Mouse, do you mind if I volunteer you?
Yeah, I just gotta get on my computer because I was watching this on my phone. Give me a second.
Mark and Mouse are a couple of our mods, so they're pretty great.
Oh, great. Super. All right. Well, thank you very much for your help, Ryan.
Yeah, appreciate it. Thank you.
I'm just going to point out another. I'm going to point out something else interesting that was done here that I had not seen before on the other 3D projects that I've been on. And I think Christoph mentioned this, that parts of the object